Mitsutaka, did I say Mitsutaka Takada, right, from Japan? And let's go ahead with that.
Thank you. I'm Mitsutaka Takada. I'm working in the Nagoya University. So I will talk about the implementation of SBN with SpaceWire module in my presentation. My research objective is to develop effective method and a tool chain for the embedded system using software platform. My research domains is aerospace and automotive. In the aerospace domain, JAXA and Nagoya University collaborate to study ways more effective to use SpaceWire into the spacecraft. And other side is automotive. We have developed the software platform and the tool chain based on all the specifications. Yeah, and at first, our motivation to use CFS. Next, I explain how to integrate the SpaceWire module with SBN. And before using SpaceWire module, we confirmed how to build method and load setting of SBN using UDP module. And we check the status, current status of SpaceWire module in SBN source code. As asked, I will talk about implementation of SpaceWire module by SpacePi, which is this Raspberry Pi 3 external board. Motivation. In Japan, SpaceWire is adapted as an intra-satellite network, mainly medium or large science satellite. By using SpaceWire flexible network configuration and remote access with RMAP protocols become possible. However, since application developers are required to know the conditions and SpaceWire specification requirement to know the constraint, to develop the communication applications. Standard interface and platform as need to expand that as the usage. In satellite application, the development, we think that bundle standard interface and software platforms such as SOAS and CFS and so on, important. So that we have been examining the use of CFS and porting for spacecraft on board in the collaboration with JAXA. What are the conditions of spacecraft software platform? In considering software platform, we conducted a survey with the following conditions. SpaceWire protocol service can be used from the applications. And open standard API or open source software are provided. And the specification is available both within and outside in Japan. So we, following specification are beginning integrated JAXA internal software platform and the document and SOAS and CFS. So SBN build method and loading setting. I researched the SBN build method. At first, I checked the build and load method using UDP modules because I use SBN for the first time and I begin as a CFS application. I explained the build method. Oh, sorry. Okay. And build method with makefile. Copy the SBN and the software SpaceWire module folders to copy to the CFE applications for that. And next, modify the SBN makefiles because of maybe a previous version is SBN net IO and SBN load IO. This is existed, but the newest version is not contains. And second and last one is modify the build makefile and attaches SBN and SpaceWire module. And the load method is SBN is one of the applications for CFS, and SBN starts at like other CFS applications by setting SBN as CFE app with a script file. And SBN protocol module also built according to the classifiers of the CFE application. But the SBN loads module to be used from the binary table file to be read at startup without loads from script file. And the current status SBN module. There are status of there are set of SBN protocol module in the SBN version 1.10 versions. 5 protocols: UDP, TCP, DTN, serial, and SpaceWire module are released from the GitHub repository in SBN. But there is a SpaceWire protocol. However, unfortunately, it does not support the latest versions. So interface structure remains as a previous version. And since there is no body code of the SpaceWire module, actually transaction and decision cannot be performed. So there is a use case of the SpaceWire communication application via SBN. SpaceWire application is registered as one of the CFS applications. SpaceWire middleware ID assumes the SpaceWire device driver for RTOS. We don't use SB this time. The main focus of study is that SpaceWire module can be operated via SBN interface. So, talk about SBN. I think everyone knows that SBN has. I think SBN has the following features. SBN is one of the CFS applications, and SBN is an application of inter-processor communications. And yes, and socket or file description interface uses communication between lower and SBN. However, I think that we can call device driver interface directly in SBN protocol modules. And any communication protocol can be used. And SBN and SB has a publish and subscribe function and update communication information with a peer table. So there are two rules in this study. We should develop a SpaceWire module in SBN interface compatible. So second is send or and receive the SpaceWire packet with SBN interface. And the last mission is communication between SpaceWire and sender node sends SpaceWire data from the CFS application. and the receive node is waiting for reception and check the transfer data with receiver data. I will talk about SpaceWire on this side. SpaceWire is a reference board for the SpaceWire appliance. This is a Shimafuji Electric product in Japan. So this communication board supports 2 SpaceWire ports. And this board compatible with Raspberry Pi 3 extension connectors. Shimafuji Electric provides a sample programming for SpaceWire applications. And this application is running via SPI driver for Raspberry Pi 3. It is also possible to use SpaceWire standalone without connecting Raspberry Pi 3. In this mode, it will be used in the SpaceWire target mode of ARMA protocol. So this slide is changes of SpaceWire module at SBN 1.10 versions. At first, we changed the file name of the modules because of naming convention is changed for the newest versions. And changes made it to makefile and included directly in compiler file, C program files. And second is updated data structure beyond net. SpaceWire module has only startup entry point for the loading module. So we have removed the entry point data structure because loading method was changed. And third one is update module API table structure. Because of newest version is API table is changed. So we implemented only API necessary for SpaceWire communications. And next, adding the event ID, a new header file. And the last one is implementation of SpaceWire service body code. We have supported only SBN APP message as a message type. And we have realized SpaceWire communication using SpacePi at low cost. This slide is about the beyond net data structure. So the data structure of beyond net is different for each protocol modules. So what should be described in peer and data, peer data on the net data of data structure of SBN. So this figure is shows simple SpaceWire network topologies. If I choose a blue line, a network, these elements are necessary for communication configurations. Path address and logical address, reply address, and key, and SpaceWire protocol ID. So we have set these 5 data elements as peer and net data structures. And this slide is an API list of SpaceWire module interface. This is a standard SBN interface named, and the UDP protocol is implemented. And we have developed only 5 APIs, so we don't use peer table this time. Therefore, we cannot support all the functions of SBN. We created only the API which can realize the minimum SpaceWire communications. And we created a demonstrate to confirm the operation of SpaceWire module. These are two SpacePi. I will use this one. And this one is a high potential ADDA board with connected to the SpacePi. And this is a SpaceWire target board. On the other side, this is a SpaceWire initiator board. SpacePi, Raspberry Pi 3 is connected to a SpacePi. Two SpacePi is connected to a SpaceWire cable, but this cable is Ethernet category 6 cable. To demonstrate the SpaceWire application, send from initiator to the target board by SpaceWire packets, and then target board sends the sensor data to initiator. This is SpaceWire reply packet. And SpaceWire application is waiting for a reply packet. When application has received the reply packet, it has displayed the sensor data. So, conclusion. The SpaceWire module has been adapted to some SBN interface API. SpaceWire communication was able to be performed from the CFS application using SBN interface. So there are future plans. I will think about this study is using a makefile process, build process. I will migration to make build process. And next, implementation of a non-support SBN interface. And I will research the use case on SpaceWire upper layer protocol for CFS application. So RMAP, SpaceWire R, SpaceWire D protocol specifies complex communication programming. So we think that similar functions are redundant for use in this example, change peer table and heartbeat SB message and communication use case, multiple protocols. That's all. Thanks.
Questions?
So on your Raspberry Pi, you showed the two boards connected, and you were running the Ethernet cable, RJ45. Were you running the SpaceWire protocol over that, or was there a translation from SpaceWire to Ethernet and back again?
Yes, physical cable is Ethernet cable, but this logical data is SpaceWire protocol.
Okay. Thank you, Takata. Oh, one second.
Just that maybe to help out with that, you can do at lower rates. They've been able to do SpaceWire on Cat7 cables, so I think that's probably what they're doing there.
Thank you.
Thank you very much.